Dr. Mohaga, and today we'll be talking about the lesson of pressure. In this lesson, we're going to understand the definition of pressure, its equation, and what affects pressure. Pressure is defined as the force per unit area on a surface. It measures how concentrated a force is on a particular area. It's a scalar quantity. Pressure is force over area. Knowing that force is, of course, in newtons, area is in meters squared, pressure is in Pascal, which we write as capital P, small a. Pascal is only applied if my area is in meters squared, not in centimeter squared. A smaller area leads to a higher pressure for the same force. A larger area spreads out the force and reduces pressure. Here's an example. A box exerts a force of 600 Newton on the ground. The area of contact with the floor is 1.5 meters squared. What's the pressure? Pause the video and unpause to check your answer. Pressure is force over area, 600 over 1.5, 400 Pascal. Why did I write Pascal? Because force is in Newton, area is in meter squared. So how do force and area affect my pressure? Pressure increases when the force increases. Imagine if you're pushing on something, you apply a lot of pressure on it. However, pressure increases if the area decreases. Here I'd like to give the example of a person or a woman wearing heels versus a woman wearing Skechers or sneakers. If you are wearing heels and you're standing on the ground, you're going to apply a lot of pressure. But if you're wearing Skechers or sneakers, you wouldn't. So here, the area is very, very small, which makes the pressure more. Here we have a large area, so the pressure is less. Pressure decreases when the force decreases, and as we just said, the area increases, spreads the force out. Here's an example. Try it on your own and unpause when you're done. A knife has a sharp edge, so small area, while a spoon has a rounded edge, so large area. Differentiate between the pressure they exert with the same force applied. The knife exerts and cuts easily because it has a small contact area. The spoon spreads the force and does not cut because it has a large surface area. Pause the video, try this example, and unpause when you're done. A person can lie safely on a bed of hundreds of nails without injury because the hundreds of nails provide a large or a small surface area. A large surface area. So the total contact area is large due to many nails, so pressure at each point is low and the skin isn't pierced. Pause the video, try this on your own and unpause when you're done. Tractors have wide tires to move over soft ground without sinking. Wide means large surface area. So the large surface area reduces the pressure on the ground, preventing tractor from sinking into mud or soil. Now let's talk about the pressure beneath the surface of a liquid. The deeper you go into the water, the pressure increases. Why? Because the deeper you go, the more liquid there is above you, exerting weight on you due to gravity. So the greater the depth, the more weight of liquid above you, the higher the pressure. The greater the density, the heavier liquid per unit volume, so the higher the pressure. Pressure is directly proportional to depth, density. Here's an example. Divers feel much more pressure at greater depths underwater. At greater depths, the weight of the water column above the diver increases, so pressure on the body and suit rises significantly. Here's another example. Dams are built with thicker bases than tops. Why? Pressure increases with depth, so bottom part of the dam must have a large base, a thick base, to withstand the greater force due to the high water pressure. Finally, at the same depth, mercury exerts more pressure than water. Why? Because mercury has more density. Mercury is much denser than water, so even at the same depth, the pressure beneath mercury is higher. That's all for today. I'll see you next lesson. Have a good day.